Testing, testing, 1, 2, 3, testing, testing. Good. Looks like everything's working. Good. Magnificent. Good morning, fancy meat computers. How's everybody doing today? Doing well, I hope. Hopefully. Hope, hope, hope. Hippity hoppity hoop. I believe today is the last class we're going to have before the test. If I've got my thoughts in order. I think we do. No, wait, do we have class tomorrow? Briefly consults interior of briefcase where schedule is laid out. We do have a class tomorrow. Okay. Well, in that case, that class will be the last class before the test. Good morning, good morning, good morning, good morning, good morning. All right. Tired. Well, there's a lot of that going around, I can tell you. Bonjour. Comment ça va? That is almost the extent of my French, despite having studied it for, however many years you study it in school in this country. What time is the test tomorrow? Fantastic question. Let's see if it's been posted. Doodly boop boop doodle 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 doodle. Yeah, that rings a bell. Did I put it on the syllabus? Wait. Did somebody put it in the calendar? Upcoming events. Nope. Odd that it hasn't been posted. Odd that it hasn't been posted. Let's see. I'm just gonna send a quick message to the TAs and request that someone posts it. Why isn't my keyboard working? Oh, it is. It just... Alright, it was just delayed. Ha! Fantastic. I love having minions. Just tell them to do things and they do it. I posted it way back in September. Ah, yes. Right. Oh, pardon me. Well, it deserves to be reposted at any rate. Probably a few people in the class have forgotten we even have a test coming up. So there you go. So, any questions about the test? One person, up to what lesson is the midterm on? The response there is recursion. Yeah, you guys haven't done the assignment on the numerical computation stuff yet, I believe. So yeah, that would be correct. So yeah, structured data types, functions, and recursion. Yeah, capici? Good. All right, we need to motor, so let's get going, eh? So. So we were talking about testing. We were talking about the various... Oh, no. I'm going to have to go get a Kleenex. Pardon me for just a moment. I'll be right back. Sorry for the interruption, but that'll be better than listening to me sniffle through the whole thing. So, gotcha. So we were talking about testing, the various types of testing that go on, how you might go about, basically broad categories of testing things that you need to think about with respect to software correctness. We just got on to, we had finished talking about regression testing very briefly. Once you have a bug established, right, you always want to, or once you've had a test case that has correctly identified a bug, you always want to keep that test case around and continue to retest it as you're developing the program, because it, especially if your solution to the bug hasn't been that good, i.e. it has been a kludge, it is entirely possible the bug will come back the very next day. The bug came back, you thought it was a goner, but the bug came back, it just wouldn't stay away. If you keep some old test cases around that correctly identified the bug the first time, and retest them periodically, then you will know when the bug comes back the very next day, and then you can perhaps fix it properly this time. So that's regression testing. A thing that has been a thing more recently is something called continuous integration testing, CIT. When you use code repository tools particularly, GitHub comes to mind most particularly, there are subsystems that you can set up so that your repository will reject code changes that introduce bugs as tested by a particular suite of test cases, which is kind of cool, right? So code repositories, very briefly, are archive systems which allow multiple users to work on the same project with minimal interference with each other. One website that is quite popular for these types of things is called GitHub. Hands up in the chat. Oh, no, I'll do it in a poll. Do you have a GitHub account? If I'm the one teaching you 1xC3 next semester, you'll do quite a bit with Git and GitHub, and you'll actually learn how to do continuous integration testing on GitHub. Let's see, how are we doing? Well, people with faster internet tend to vote yes. Oh, quite a few of you do. This is good. This is good. So, when you push a commit, you can set GitHub up such that the code that you're pushing has to pass some tests in order to actually be added to the repository. This is a very, very useful thing in sort of team contexts, because it maintains the integrity of the code in the repository, and people are prevented from adding bugs, at least bugs that would activate the known test cases. So yeah, continuous integration testing is very cool, and it's very hip and modern, and it's the new big boy on the street with respect to testing. This is an example of it in GitHub. There we go. From some big project that the guy who made the slides was working on. But yeah, it runs checks. Some checks were successful, others were not, so it rejects the commit. There we go. So let's talk about test cases. We've talked quite a bit about means and mechanisms of tests, but what about the actual test cases? Well, developing the test cases themselves is often it requires almost a white box knowledge of the problem in order to write black box tests. And I know that's a little bit of a contradiction, but from a black box perspective, all you can really verify is that what's going in should be what's coming out, right? But you can enhance your test cases by knowing, different details, but we'll get into it. First, we want to cover all different types of input that could be provided, right? This is particularly important in Python, where the concept of typing is somewhat ephemeral and not enforced in any way. So, it's good to try a string or versus a list versus a tuple versus a dictionary versus integers versus floats, etc., etc. Try the different data types. In general, we don't hold you to that. You'll notice that, the test and the assignments, so far you've been able to operate on the assumption that the type of the arguments that we've requested is, you don't have to assume that you might be dealing with a Boolean when we've said in the question that it's a dictionary and stuff like that, although it is technically possible in Python. Other languages, which are better languages, restrict this so that, when the compiler says that it takes 2 ints in a float, or when you say that a function takes 2 ints in a float, then by gosh golly, that you can take that to the bank. So, we also need to take into account edge cases when input is at some extreme or might require special handling. So, for numbers, edge cases include the sorts of things you want to test are positive and negative numbers, 0, 1, odd numbers, even numbers, prime numbers, composite numbers, etc., etc. For strings, you want to test the empty string and a 1-character string and then the rest. Lists, empty list, one element list. For subsequences, at the beginning, the answer should be at the beginning and at the end. In general, a good way of going about writing test cases. If you're writing a test case to search a data structure for something, or do something with a data structure, you're looking for something, putting the thing you're looking for at both the beginning and the end of the data structure is very, very useful, because those are the types of places that will often get missed or skipped if you're, for example, writing a loop about it, right? The body of the loop, most people will get right most of the time. If you're going to make a mistake, that mistake is likely going to be made on the boundary conditions, which is why it's important to test edge cases. Make sense? Hopefully? Good. So let's refer back to this function that we were talking about, max product. This guy right here. So let's imagine a test case 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. The maximum product of this, as evaluated by the function written previously in the slides, is 121,927,680. This is an edge case. The substring corresponding to the max product starts at the end of the string. So if you kind of just visually inspect this number, the max product is going to be in this. It's going to be this last segment of digits, because it has the highest numbers in it overall. To move this way in the number at all means that you're dealing with lesser numbers that you're computing, right? You take off the 9 and you add a 7, and that's you lessen the magnitude the whole way down. This, however, if you calculate this by hand, is not actually correct. The correct max product, which is 7 times 8 times 9 times 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9, is 181,891,520, which is different from the number that we had before, or the number that was calculated from our algorithm. So we know we have a bug. So the question might be, how do we arrive at this number, given that we're not arriving at it using our function that we wrote? In this and other numerical examples, it's reasonable to verify these things using a calculator. Like, perform the calculation yourself by hand, right? Particularly if it's something very simple like repeated multiplication. For more complicated algorithms, obviously it gets more difficult, but in general, the piece of terminology that's generally used is you have a test, like, in order to create test cases, you need an oracle, right? An oracle is someone who, like, knows the truth but mysteriously, like a fortune teller. Like, it goes back into ancient Greek thought, but at any rate, and Roman thought, but at any rate. So, in this case, you, the individual person, are functioning as the oracle. You know what the truth is, or at least you can find it out. In other cases, especially when you're trying to produce an optimization of an existing algorithm, or an existing program which already works, it already works, it produces the correct results, you just want to produce those results using fewer system resources or whatever. You want to apply all of these algorithmic techniques that you've learned in 2CO3 to your problem in order to get it more efficient. You can use the old slow version as an oracle to produce test cases for the new version that may not be correct. This is actually, roughly speaking, how we produce the test cases for your assignments and tests, etc. We write the we design a problem, right? Actually, I'm going to let you in on a little secret. When we make the problems, we'll make the code first. Like, we will write the algorithm, then we'll write the question to the algorithm, right? The test cases are us running inputs on the instructor solution, and then just giving you the results as the we want you to get this value in the test case, right? This is why, generally speaking, in cases where there is a conflict, hopefully these are rare, but where there's a conflict between the test cases and the wording or description of the problem in the actual question, you may have noticed that both myself and the TAs have a tendency to side with the test cases rather than with the wording of the question, because unless the problem is quite egregious. The reason for this is that the instructor's solutions are considered primary, and that the process of encoding an algorithm in English text is inherently fraught, and that that translation is much less likely to be translation of an algorithm into English is much less likely to work than simply the running of an existing algorithm. So that's why the test cases are in general considered correct, unless there's a bug in the instructor solutions itself. Yeah. Yeah, hello, Mark. Mark's listening in. We are reasonable people. If the test cases can be proven wrong, we will change a test case. Sometimes we miss it. Yeah, we're not perfect. Sometimes we do make mistakes in the instructor solutions, although they are subjected to quite a bit of rigorous examination. But if we do make a mistake, we will, of course, fix it. no process is perfect, but Mark, you would agree that like we certainly consider the test cases to be like primary over the question descriptions, right? I'll just give Mark a moment. I'll do the slide while he's responding to that. So, again, test cases should be produced from some kind of mechanism independent of the program that you're trying to write. Whether that's another program or your calculator, it doesn't make sense to produce it doesn't make sense to produce, you know, the thing you're verifying the program with from the program itself, right? Yes, and Mark has confirmed. There we go. So, it's not always possible to have an independent method. If not, we try to check design cases. We try to design test cases that check for consistency. For example, 2 test cases that should return the same result, right? So in this example, we have our test case from the last slide for max product, and we have another test case that should return the same result, right? Adding a 1 on the end here should not change the value of the maximum 12 adjacent, the product of the maximum product of the, 12 adjacent numeric characters. Because we have not changed the rest of the string, we've only just added a 1 on the end, and the bracket should stay exactly where it is. However, if we were to actually run this on our algorithm as given at the beginning, because of the bug, these two would not be equivalent. Good. So the problem here ends up being an off by 1 bug. This 12 should be an 11. The result of that is that the algorithm is actually stopping 1 short of testing the subrange that's in the maximal position of the array. The subrange that's at the end of the array. We're stopping 1 short of that because there's an off by 1 bug inside of the loop here. So, there we go. So let's talk about white box testing very briefly. White box techniques rely on knowledge of the program's source code. It is possible to test programs far more thoroughly with white box testing, or white box techniques than with black box techniques. Black box techniques are excellent for indicating that there is a problem. White box techniques are more useful for actually fixing the problem. So, in general, there are a couple of different ways of going about it. The first one is code review, a process where 2 or more developers visually inspect the program code. Mark's there. All right, I'm out. I just wanted to let you know I made the announcement that a question exists in Slack for you to review when you get a chance. Okay. Peace, Mark. I'm lecturing until like 11:30 today, so I'll get to that as soon as I can. So the developers that do this type of review are generally senior developers because they know what they're looking for. They'll be checking for programming best practices. That is to say, they will be critiquing your stylistic decisions. Like, if you write your code in such a way that it's almost impossible to read, they will tell you that and tell you to fix it. They will look for potential inefficiencies and look for common vulnerabilities. There's like a general set of common problems that you can pick out pretty quickly by inspecting code if you know what you're looking for. Code review tools can help the process. some of these things that you look for can be encoded in automated tools that scan through your code and tell you what problems you have. One good example of that is a program that we talk about in 1xC3 called CPP check. Of course, it's applying to C or C/C++ code. Here it is. CPP check, a tool for static C++ code analysis. So essentially, if you have a program, a C program, and you feed it into CPP check, it will tell you, it will scan it for a very large, like a broad set of common vulnerabilities. You know, division by zero, dead pointers, overflows, memory management problems, null pointer dereferences, which will just crash your program in C, and all kinds of other, you know, common mistakes. And you know, it's a very useful tool. There are formal code review methodologies, and they can be very time-consuming. You can also do very fancy stuff like formal mathematical verification of code, which is what my thesis was about, basically. Can you give us some examples of common vulnerabilities, or is it out of scope right now? Well, I'm not sure how common it is, but I can tell you a story about an exploit that a student found in this class, which potentially allowed that student to get nearly perfect on every assessment without having to actually do the questions. And this is kind of a very Python-centric story. Basically, everything in Python is an object. Python doesn't check that the return types of functions are particular types. It just returns anything you ask it to. Needless to say, in our, you know, we've since fixed this vulnerability, but at the time, you can imagine that equality comparison was a very commonly used operation in our test case analysis, right? Somebody with some person with very clever pants on discovered that if you design a class, right, that overloads the equality comparison operator to always return true, which is totally possible in Python. It's actually very easy to do. And then you return an object of that type, of that class, as the return value from your function. When the testing code went in to test it for equality against something else, it would always return true, no matter what the case was, right? No matter what it was trying to test it against. Yes. And that was like, that completely blew up our testing. That completely, like, that broke the autograder, essentially. And especially because this person, like, posted it publicly before they talked to us about it. We were scrambling because we suddenly had to fix everything very quickly. We did. And I'm not going to tell you how, because if I tell you how, people are just going to exploit that. But yeah, no, it was terrible. It is. It's like, that's like the essence of like a really like that's the essence of really good programming, unfortunately, is like you have like a very simple solution that just good algorithms do not have to be complicated. And this algorithm was not very complicated and just blew everything to pieces, right? So yeah, so that's a situation we dealt with in the past. So now again, I'm not sure how common that vulnerability is, but you know, basically it comes back again to this problem that Python is a child's toy, and at some point you have to learn a real language. Do we get a syntax sheet like on the first midterm? Yes. Yes, you do. So, another very important aspect of white box testing is what's called coverage testing. So, if you think about where bugs can hide, there might be a bug on any particular line of code in your program, right? So, in an ideal world, you would have a set of test cases written which exercises every single line of code that you've written. Every line of code must be actually run at least once. That being said, it's impossible to know if you're doing that without performing code coverage checks. And again, I'm more familiar with this in a C context, but there are tools. Excuse me. There's a tool called gcov, which you run your program, and gcov will create like your source code on one side and a tally of how many times each line of code was run on the other side, and that way you can quickly and easily like pick through and see if there are any branches of code that haven't been run. So that's code coverage. Static analysis is a general term for automated tools for finding flaws in programs. The reason it's called static analysis is because it doesn't actually run the code. It's just analysis of the syntax, the grammar. Again, my thesis work was to produce a static analysis engine for a hardware description language. But so if you want to ask me about that sometime, maybe after class. How did we fix it? Again, I'm not at liberty to discuss those details. Debugging. Once your testing has shown that your program does not behave as intended, you have to identify the bug and fix it. To find the bug, you need 1. A test case that reliably fails, and 2. You need to try to understand the internal state of the algorithm. This normally means performing a trace. So, yes. So often when you're like submitting a bug report to some person who's working on something, they will. The first step for receiving a bug report is to determine whether or not the bug actually exists, right? Because, especially if you're getting bugs from like your general user base, you will likely receive a lot of bug reports that don't actually correspond to bugs. They're just things that the user didn't expect the program to do, or things the user thinks are a bug but you don't think are a bug. Stuff like that. So that's you throw away those bugs first, bugs that don't actually exist. The next set of bugs you throw away are bugs you can't reproduce. If, as a developer, you can't reproduce the bug, you can't fix the bug, right? You need to be able to see the internal state of the algorithm while the bug is occurring in order to know how to fix the bug. So, if you can't reproduce the bug, then you type into your bug tracker, can't reproduce, close ticket, right? Understanding the internal state of the algorithm, basically there are 2 main approaches. Number 1 is to use print statements, which is probably what most of you have been doing so far. The second is to use a debugger to step through the program. Incidentally, I would qualify Python Tutor as being a debugger. It's a debugger that allows you to, it has a timeline that you can scroll through, so it's almost like it has saved a series of breakpoints. Like, it considers each line to be a breakpoint and allows you to scroll through them and watch as the state changes. It's a different approach to debugging than that you normally see. It only works on smaller programs, but fortunately, the programs that we're running are smaller in the majority, so it works pretty well. But if you're debugging a larger program, you're going to have to use a somewhat more complicated methodology. So debuggers generally integrate with editors and allow you to visually inspect source code and the internal state of the program as it is running. You can use debuggers to cheat in games. Oh, yes. Oh, absolutely. Yes, yes, yes. You can step through each line of code one at a time. You can set breakpoints and run the source code until it reaches a certain line of source code, and then let it pause and let you inspect it. How? How can you use a debugger to cheat in games? Well, okay. Very brief tangent. You know the Pokemon, like the original Pokemon games, Red and Blue, the speed runs that they do for Pokemon Red and Blue, right? You know how they can get you to, like, the final, like, the credits in Pokemon Red without even having picked up a Pokemon first, right? So essentially, the Pokemon games are, like, written in assembly code, right? That assembly code, you can deconstruct that back into the original source code, right? And what people noticed while performing traces on this original source code is that you can fool the program pointer into thinking that it's anywhere inside of the memory, which is actually something you can generally do on systems that don't have operating systems, like the Pokemon games. The Pokemon game is just a game. It doesn't like any operating system presence in the original Game Boy was minimal at best, right? So what they discovered is you can tweak the game in such a manner that you can place the program pointer to other regions of memory than the processor instructions for the game, right? Which means, and this is called arbitrary code execution bug, right? Or an arbitrary code execution exploit. At that point, it's basically just a matter of finding, some sequence of bits, stored inside of some image file somewhere that happens to be the instructions to, like, enter doorway, like, enter the last game's, like, the last room in the game's doorway, right? If you can find that series of bits, and if you can manipulate the program pointer to jump to that, that location in memory, execute that code, then there you go. Arbitrary code execution exploit, you warp right to the end of the game. But it's impossible to know that, it's impossible to know any of that without being able to see the internal state of the program as it's running. So that's where debuggers come in. But yeah, there we go. Would we be allowed to debug our code for assignments using the latter mentioned Python tutor? If you're not already doing that, then you should start doing that. Never trust the client. Yes. Yeah. It's kind of cool, actually. Yeah, some older versions of the Pokemon arbitrary code execution exploit, like, you can actually take your player inventory, put particular items in a particular order in the player inventory, and those will code for instructions if you manage to, like, coerce the program pointer to read your inventory as program instructions. It's very cool. It reminds me of the arbitrary code execution in Super Mario World, where you can just write bits of code by jumping at certain locations in the game. Yeah, like, These older games are a lot of fun for that type of thing. Like, yeah, just I don't know. Video games were more fun in the 90s. I'm just gonna put it out there. But anyway, so idle is an integrated development environment for Python. It's built into all Python installations. If you want to run it, run by typing idle3. So Anaconda, if you've got Anaconda, you've got idle. This is what it looks like in a Mac at least. You've got your code on one side, you've got your Python interpreter on in the middle, and then you've got a debug control. And you can see that local variables and local variables are given the in particular, you can select a line of code, set a breakpoint, run the code until it hits the breakpoint, at which point you can step forward, step backward, and then, or just continue on until you hit the breakpoint again. This is much, much more efficient than just saving all of the state that the program has, because if it's a sufficiently large program, that's not going to be possible. Check out the one in Ocarina of Time. Maybe after class. So, all right, let's talk about exceptions. This is the actual bit where you learn coding and junk. So, let's think about program correctness, right? Let's suppose you want to create a function that creates that returns the maximum number in a list, ignoring the fact that Python already has a function for this. What should the function return if you input an empty list? Where empty lists are a perfectly valid edge condition on any program that accepts lists as inputs. So, should you return 0? No. 0 may not actually have been in the list, but then again, it might have been. Then again, 0 might be a valid maximum element in this list. If all of your elements in the list are negative integers and 0 is in there, then 0 is the valid maximum. So in general, if you want a error result or a non-result, you don't want that occurring inside the domain of valid responses. That's just generally a no-no, right? How about infinity? Well, maybe, but no. Some programming languages maintain a not a number value. Both of these previous ones you could maybe express as the none type in Python. So Python has a none value, which you can use to sort of say, this returns nothing. Just, you type it like none, return none. Like that. Oh. How about returning false? This is how we've been solving things in the core, like so far. When we want to indicate that a result is invalid, we return false. However, this isn't a great plan either. You have to check for that each time. Also, if you get into lower level languages like C, false is actually the same thing as 0. So that's how the Booleans are actually defined in C. False is 0 and true is anything that isn't 0. Is that equivalent to null? Yeah, none and null are equivalent concepts. Yes. I see we have a Java programmer in the crowd. So let's consider if max and min were returning false. If we wanted to write another program which calculates the difference between two, the max and the min, for example, this negative sign becomes problematic because we can't use a subtraction operator on Boolean values. Just to verify, Python 3. True minus false is 1. you can actually. False minus false is 0. False minus true is -1. So you can see, you can sort of intuit here that true is 1 and false is 0, right? In any case, you're not getting what you think you're getting, right? True is equal to 1, false is equal to 0. Yeah. True and false are the same thing as 1 and 0 in Python. Really cool because you can add them. Bool is just a subclass of int. So the slides are technically incorrect here. We can use subtraction operators on Booleans. It just coerces them into integers, which is probably not what you wanted. Yeah. I think this is where I think Rust does it best. They have an optional type which forces you to check the validity of value exists. Some unknown value would check if the unknown value exists. Yeah, that's the same as Haskell's maybe type. Or it sounds like it's the same as Haskell's maybe type. It can sometimes be useful because you want to put conditions inside of algebra if you're being really creative. Yeah, like you have there's certainly stuff you can do with it, right? But you know, in terms of functions, behaving how you would expect them to behave, right? If we're returning false and false is 0, basically we're in the same position where we're returning something as a failure value inside the domain of valid return results, which we don't want, right? This is why, languages like Haskell and Rust use things like the optional type. Use things like optional types or maybe types when something might fail. If max and min returned false, right, we would have to check for them and return false from bound in the case that we got false from A or B. You can see how cumbersome this has become, right? We want to just be able to do this, but instead we are forced to blow that up to like 5 lines of code. Gross. Gross. The answer is exceptions, and we'll talk about them next time in class. Are there any questions before I terminate the stream? What's my favorite Pokemon game? Emerald. It's got to be Emerald. What should you do to get ready for the test? Coding Bat, you guys should be beyond Coding Bat by this time. The Coding Bat problems are now too easy. In general. There are some problems on Avenue. Let me just take a look here. Practice test 2 _ master under the week 7 folder. Under the week 7 folder, use your intelligence to select for those problems which are, relevant There are some, like, topic 6 problems in here, which would probably be good practice at any rate, but there are 8 problems in there which are good. So I would start there. Sound good? Sorry if it's obvious, but can we use Jupyter Lab on the test instead of Notebook? Yes, in general, Jupyter Lab and Jupyter Notebook both, like, they both store the notebook files in equivalent formats. So, like, the main thing we're concerned about is us being able to import into our Jupyter, our JHub server and everything working without having to worry about too many formatting issues. So, yeah, from what we've seen, Jupyter Lab, there's no issue. So, yeah, Jupyter Lab is permitted. Is the format of this midterm the same as the last one? Yes. Would you say the difficulty of the practice test is similar to the actual test, or is it much easier? I'd say on a question-per-question basis, the number... The practice test has more questions on it than the midterm does, but those questions are, I would say, roughly equivalent. I'm not at liberty to discuss the exact number of questions, but yes, it is 1.5 hours. Back to the... Oh, favorite Pokemon. Favorite Pokemon. Oh, jeez. Answers to the practice test. Do we have that? I don't think we have that. Sorry. That'll be a testing exercise. You can test your own work there. I don't know. I'd have to think about it. Imposter Ditto. Imposter Ditto or Wobbuffet. One of those two. You can beat pretty much anybody with... You can beat pretty much anybody or anything with a Wobbuffet. Sometimes you can even take out two of their best guys just with a Wobbuffet. It's amazing. You just have to memorize which Pokemon uses special versus attack type attacks. Mark said there's 3 questions and a bonus. Well, if Mark said it. Are our classes online for the whole month? Possibly just these 2 weeks. I'm saying 2, maybe 3 weeks. We'll see. Yeah. Yeah, Shadow Tech. Yeah. Now that he has the ability, it works. Most people are stupid enough to not use status moves on Wobbuffet. But, anyway. I gotta get to my next class. Take her easy.